Hi, and welcome to my channel. Today, we are going to review the AWS Security Specialty sample questions available on the AWS certification homepage. Let's start with the first question. Here, we need to keep the communication between VPC and KMS inside the AWS network. And we are not supposed to use the public endpoints. Using a VPC endpoint, we can keep the traffic between VPC and KMS inside the AWS network. But KMS is also accessible from the internet. So to prevent internet requests, we need to include a resource-based policy in the KMS key. The question is asking you to select two choices to satisfy this requirement. Choice A talks about adding a source VPC endpoint check to the key policy. Now, this is a valid option as we need to limit access to the key only using a specific VPC endpoint. So A is a possible answer. Choice B talks about removing the VPC Internet Gateway and adding a virtual private gateway to the VPC. Now, if you recall, the question states that we need to keep only the KMS communication private. I feel we don't need to remove the Internet Gateway because other servers in the VPC could need Internet connectivity. Also, a virtual private gateway is used for VPN connection in a hybrid infrastructure, which is not applicable here. So we can eliminate choice B. Choice C talks about creating a VPC endpoint for KMS with private DNS enabled. This is required. But what is this private DNS option? What exactly does it do? When your application communicates with AWS services, it uses a regional public endpoint for the service. When a private DNS is enabled, VPC would automatically route public endpoint requests through the VPC endpoint. So your application would continue using the regional public endpoint, but behind the scenes, VPC would automatically send the traffic using the VPC endpoint. So A and C are possible answers here. Let's look at other choices. With choice D, KMS import key feature or a VPN. Now, we don't need to use a VPN for this question. And this choice covers only the import key action. But what about the other KMS operations? So clearly this is an incorrect choice. Finally, answer E suggests a key policy with source IP-based conditions. The 10.0/16 CIDR specified here is private. An important point to remember for IP-based conditions in a resource-based policy is we can use only the public IP range. Think about this for a second. Private IP is valid only inside the VPC. And not only that, multiple VPCs can use the same private IP. So this choice is also incorrect. Let's go ahead and cross-check the answers. Choices A and C are indeed correct. Let's look at how a key-based policy would look like for this use case. This policy has two statements. The first statement allows all KMS actions when the principal is the root user or any of the delegated identities in the account. However, the second statement denies all critical KMS key operations when the request is not through a VPC endpoint. So this policy will ensure critical KMS operations are performed only using the VPC endpoint. The next question is about CloudWatch logs. Here we have two applications, and one of the applications produces logs that contain sensitive data. We need to design a solution such that the application logs are kept separate. The emphasis here is least risk and effort. When working with CloudWatch logs, we need to create a separate log group for each application. Using a single log group for both the applications will mix log events and cause all kinds of issues. So a best practice is to create application-specific log groups. Let's look at the answer choices. Choice A talks about using CloudWatch log groups to capture all data and then separate using a Lambda function. This option looks like a lot of work. Remember, the emphasis of the question is least risk and effort. This approach is both risky and requires a lot of effort. Choice B uses 2 log groups, one for each application, and then control access to log groups using IAM policy. This option is indeed the recommended approach, so B is a valid choice. Let's look at the other 2 choices. Choice C aggregates log data to a single file. We definitely don't want to do that. And option D uses instant storage along with a batch script to move to a secure location. This once again is a lot of work, so among these choices, B is the only one that makes sense. The third question is about security groups and how to protect a 3-tier application. Users access the presentation tier over the web, and this is protected using the presentation security group. The logic tier has RESTful APIs that is called by the presentation tier or HTTPS. This tier is protected using the logic security group. Finally, we have the data tier that has a SQL Server database accessed over port 1433, and only the logic tier is allowed to call the database. So we need to choose the security group configuration that will allow the application to be secure and functional. There are 3 answers that we need to pick. With choice A, presentation security group allows port 80 and 443 access from anywhere. Port 80 is for HTTP and 443 is for HTTPS. We need this rule as web users access the presentation tier. The next choice, B, allows data tier access from the presentation tier. This does not meet the requirements as only the logic tier is allowed to talk to the database. So we can eliminate this choice. The third choice, C, allows data tier access from the logic tier on port 1433. This is a valid option, so we need to use this rule. The fourth choice is invalid as it allows a data tier to interact with the presentation tier. With choice E, logic tier allows port 443 access from the presentation tier. This is a valid rule and we do need to include this. Finally, choice F, the logic tier allows 443 access from anywhere. Now, our requirement is that only the presentation tier can talk to the logic tier. So this particular rule will not meet that requirement. So among these rules, only A, C, and E are valid. For the next question, we have a web application with the following components. S3 is used for hosting the website, API gateway for RESTful services, DynamoDB as the database, and there is also an existing SAML provider that has the user identities. And only the users in the SAML identity provider can access the web application. So we need to pick 3 choices that support this configuration. Now, SAML identity providers are natively supported within AWS. Let's look at the answer choices. With choice A, we need to create a custom authorizer using Lambda. This is not needed as various AWS services support SAML integration. With choice B, we need to configure SAML identity provider in Cognito and map to Cognito user pool. Cognito indeed supports SAML integration, and we can map SAML identities to the Cognito user pool. So this is a valid answer. With choice C, we need to configure SAML identity provider to add the Cognito user pool as a relaying party. We do need to establish trust between SAML and Cognito. So this step is also required. Choice D talks about integrating social identity providers such as Google, Facebook, and so forth. For this question, we need to allow users in the existing SAML provider. So we should not be using social identity provider, so this is an invalid choice. Choice E is asking you to update DynamoDB to store email and password. Once again, all users are already there in a SAML compatible identity provider, so we don't need to store users and passwords in DynamoDB. So this choice is also invalid. With choice F, configure API gateway to use Cognito. This step is needed to authenticate and authorize calls to the RESTful services. So among the choices, B, C, and F are valid and it meets the requirements. The next question is about a resource-based policy for an S3 bucket. Users need the ability to read the objects, and this is the policy that is currently applied to the bucket. However, the user is getting an error that says action does not apply to any resources. So the question is how to fix this error. Let's look at the policy. The action has getObject and getObject version, which is indeed needed to read the objects. The effect is allow, which is also good. The principal is star, which is everyone. However, if you notice in the resources, we have only the path up to the bucket. This is a common issue that you will encounter when you work with S3 buckets. So to fix this issue, we need to specify all objects in the bucket using a /star. Let's look at the answer choices. A is talking about adding put bucket policy permissions, which is not needed for reading objects. The next choice B does not make any sense. I'm assuming they're talking about specifying the correct bucket name in the resources. The bucket policy will throw an error if you attempt to save a policy with an invalid bucket name. So this is also not a correct choice. The choice C is asking us to include a /star after the bucket name. And this is indeed the correct solution. Finally, choice D is adding list bucket permission. Now, there is no action called list bucket. There is a list buckets action in plural that allows you to see all available buckets in the account. There is also a list objects action to view all available objects under a bucket. So choice D is also not valid as the error is encountered when reading an object. So the correct answer for this question is choice C. The next question is about VPC peering. Here the company has placed the database in a separate VPC. The app and web tiers are in their own VPCs. There is also a peering connection between the VPCs. The problem is app servers are unable to connect to the database. So we need to identify the next steps for troubleshooting this issue. The question is asking us to select two relevant troubleshooting steps. Choice A asks you to check if the app servers are in the private or public subnet. I don't think this aspect is relevant as servers in any of the subnets can communicate over the peering connection. Choice B is asking you to check the route tables for the app server subnet and ensure there are routes for using the peering connection. This is in fact a reasonable next step for troubleshooting connectivity issues. Here is a peering example with two VPCs. The VPC CIDRs are 10.0/16 and 172.31/16. When you set up a peering connection, we also need to update the route tables. So the 10.0 VPC has a route to the 172.31 VPC, and the traffic is routed through the peering connection. Similarly, on the 172.31 VPC route table, the traffic to 10.0 VPC is routed through the peering connection. So B is a valid choice and we need to verify if routes are correct. Choice C is asking you to check the network ACL for the database subnet for rules that allow traffic from the internet. While network ACL can indeed block communication, This choice is asking us to see if the database subnet allows traffic from the internet. We don't need to allow traffic from the internet as the communication over a peering connection is private and uses AWS network. So this choice is also invalid. Choice D is asking us to check the database security group rules to allow traffic from the app servers. This is a valid next step as an incorrectly configured security group firewall may prevent servers from communicating. Choice E is asking us to check if the database VPC has an internet gateway. Now, app-to-database communication is over the AWS private network, and we don't need an internet gateway, so this is also invalid choice. So among the choices, the valid troubleshooting next steps are B and D. The next question is about Lambda function and CloudWatch log. Lambda function here is retrieving items from a DynamoDB table. However, the security engineer notices that Lambda is not logging any data to CloudWatch logs. Now, Lambda automatically logs every method invocation to CloudWatch logs. In addition, you can also print messages in your Lambda function, and they will also be logged to CloudWatch logs. Now, if we don't see any Lambda entries in a CloudWatch log, it usually indicates a permission issue. Let's review the policy that is attached to the Lambda role. This policy grants only DynamoDB getItem permission. So the function can read items from DynamoDB. However, we don't see any statement that grants permission to log to CloudWatch logs. Let me show you what permissions are needed for logging. In the IAM console, go to the Policies option. Let's filter for AWS Managed Policies and look for Lambda. AWS has provided the Lambda Basic Execution Role policy. And this policy has a minimum set of permissions that you need to grant to your Lambda function. If we look at the JSON policy, Lambda needs permission to create log group, create log stream, and put events. Create log group allows a Lambda function to create a new log group when the function is invoked for the first time. Whereas create log stream allows a Lambda function to create a new log stream. A log stream usually indicates a unique source. If there are many concurrent Lambda functions executing, they all will have independent streams to log their activities. Finally, the put event allows a Lambda function to publish an event to the log stream. So let's get back to the question. The question is emphasizing on the least privilege policy addition that would allow the function to log properly. Choice A would work. However, it is also granting permission for all log actions, which is violating the least privilege requirement. Choice B grants permission only to create a log stream. This is clearly not sufficient. Whereas Choice C grants permission to create a log group, create a log stream, and put log events. If you recall, this policy matches Lambda Basic Execution Role policy. So choice C is correct. Now let's look at choice D. This one is granting delete permission, which is not required and violates the least privilege requirement. So the correct answer for this question is choice C. This question, along with question 2, focus purely on CloudWatch logs. I hope you got a good understanding of how CloudWatch log works and what permissions are needed. The next question focuses on data encryption. Here we have a data lake built on S3, and there are millions of sensitive data files. The security team has the following requirements. The data must be encrypted in transit, and data must be encrypted at rest, and the bucket must be private, and if accidentally made public, the data must remain confidential. And we need to figure out the best way to accomplish these goals. So for this question, we need to pick 2 correct answers. Choice A talks about enabling server-side encryption using S3 managed keys, also called as SSE S3. Now, SCS-3 does provide at-rest encryption. However, if the bucket is accidentally made public, S3 would automatically decrypt the objects for everyone. So this option does not meet the security requirement to keep the data confidential, even when the bucket is made public. With choice B, we use a KMS managed key for encryption, SSE KMS. Now, this option also provides at-rest encryption, and it also offers an additional layer of protection. Because the object is decrypted only when the caller has permission to access the object and also has permission to use the KMS key. So this option takes care of at-rest encryption and protecting data even when the bucket is accidentally made public. Now, we need to see how to enforce the in-transit encryption. Choice C uses a bucket policy to deny put object requests when secure transport is not used. Now, this is a great way to ensure the caller uses secure transport like SSL or TLS. So, choice C is also valid. Choice D is talking about limiting access to the bucket by using a source IP condition. This is a great way to place a network restriction. However, there is nothing in the question that specifically asks for allowing access only from the corporate network. So, choice D is also not applicable for this question. Choice E talks about MACI. MACI is used for detecting the presence of sensitive information in your bucket. It can also alert when the security of the bucket is weakened. However, it does not apply to the current question, so we can rule out E. So in order to comply with the security requirements, we have to use the choices B and C. The next question is about CloudTrail and how to retain the data for the required duration. A company has multiple accounts, and we need to ensure the API call data is recorded across all accounts. This data needs to be immediately accessible for 90 days, and the data must be preserved for 7 years. Now, let's look at the answer choices. The emphasis here is scalable and cost-effective. Choice A is talking about enabling CloudTrail in all accounts to a centralized S3 bucket with versioning enabled. However, it is moving data to Glacier every day and then expires the data in 90 days. This does not meet the immediate access requirement for 90 days, as data in Glacier needs to be restored first. Secondly, the data also needs to be kept for 7 years. So this choice does not meet both these requirements. Choice B uses multiple S3 buckets and expires the data after 7 years. While this approach is technically feasible, it is not cost-effective as the data is kept in the same storage class for the entire 7-year period. Also, as multiple buckets are used, we now need to consolidate data and analyze data across different buckets. Choice C is consolidating all data to Glacier and expires the data after 7 years. While this option takes care of retention, the data is not immediately accessible for the first 90 days, as the data needs to be restored first. So this is also an invalid choice. Choice D uses a centralized bucket to consolidate the data, and it also uses a lifecycle policy to move data older than 90 days to Glacier. The expiration is set to 7 years. So this choice is perfect and will meet all the requirements. The final question is about a user's access key that was found in GitHub. This kind of public disclosure of credentials can result in a misuse, and the security engineer must ensure access key cannot be used, and also audit if the key was used for any unauthorized activities. So let's review the answer choices. Choice A is asking to review the user's IAM permissions and delete unrecognized or unauthorized resources. While this seems like a decent step, it does not explain how exactly one would go about finding unrecognized and unauthorized resources. Choice B talks about deleting the user, reviewing CloudWatch logs, and reporting abuse. Now, there is no need to delete the user. Also, there is no mention of CloudTrail to check for unauthorized activity. And also, in this case, the user published the credentials in GitHub. So we cannot claim an abuse in this case because it's a user's mistake. So this particular choice does not make any sense. Choice C talks about deleting or rotating the access keys, reviewing the CloudTrail logs in all regions, and then deleting unrecognized or unauthorized resources. So deleting or rotating the user's access key is in fact the correct first step. In addition, we can review the CloudTrail logs to see if the access key was misused. Finally, we also need to clean up unrecognized or unauthorized resources. So choice C indeed has the correct next steps. Now, choice D talks about removing the keys from GitHub, rotating the keys, and redeploy any instances. While removing and rotating keys makes sense, the impact due to leaked credentials could be more than just instances. Also, I'm not sure how redeploying instances would address a security issue. So, choice D is invalid. So, in this case, the correct answer is choice C. So, to summarize, with these 10 questions, we touched upon some important topics related to AWS security. How to use VPC endpoint to keep the communication inside AWS private network, troubleshooting network connectivity issues, how to monitor log file content using CloudWatch logs, identity federation using SAML, managing access using identity-based and resource-based policies, at-rest and in-transit data encryption, monitoring API activity in your account, how to handle leaked credentials, and so forth. We also saw how drawing diagrams can help you analyze and answer questions faster. Now, do use this approach when you go to your test center because you do get access to your paper and pencil. So visualizing questions can help you answer a question faster as well as avoid mistakes. But this option is available only if you go to your test center. If you are taking a test at home, you are not allowed to use paper or pencil. So do keep that in mind. Now for more in-depth preparation, please do check out my security specialty course available on Udemy. I have provided the link to the course in the description. I hope you like this video. Do like and subscribe to my channel. And please do provide any suggestions you may have in the comments. Thank you.